In lesson 12.1, we're going to work on probability, and our standard that we're going to be working on is this here, 7-point statistics and probability, SP.5, and we're going to be talking about the likelihood of an event. So find the likelihood of an event. We're going to use it as an example. We're going to use a number cube, which has 1 through 6. Okay, that's called an event. What's the likelihood of when you roll 1 cube and you get a 2? Well, the likelihood of getting a 2 is 1 out of 6. Okay, so some examples that they have here. If you were working with a partner and you had a number cube, okay, so what they want you to do is to roll that dice, and what's the likelihood of coming up with what they're asking. You're going to go from labeling them as least likely or most likely. You're going to do all of these here. You're going to order them in the likelihood, with 9 being the highest, the most likely, and 1 being the least likely. So for example, if you roll a number less than 7, well, you're going to have a 6 out of 6 chances of doing that. So then you have to finish up the rest of these, and then you'll go ahead and you'll rank those. So we have some information here that we need to go over. What an experiment is: it's an activity involving chance in which results are observed. Each observation of an experiment is a trial. Each result has an outcome, and a set of one or more outcomes is an event. So you are going to do an experiment in class. You're going to look at each observation, and that is a trial. You're going to have an outcome, and then all of those are called an event. So the probability of an event, and here this is key, you need to learn to do this, how it's written, okay? It's P of an event, measures the likelihood that the event will occur, and we use 0 to 1, okay? And we can write it as a fraction, decimal, or percent. So down here is an example. This is sort of like a timeline, if you will, a number line. We have from 0 to 1, and then we have the halfway. So if we write it as a decimal, it shows here, this is the decimal, and then of course this line here shows it as a percent, and then this would be the number line. We also have some wording here that helps us out in trying to categorize where the event is occurring. So if an event is a 1 or 100% that it's going to happen, that's a certain event. Then there's likely, it's not quite, maybe you might want to say that that's somewhere maybe 80%, okay? And then we have as likely as not, or okay, that's the 50% area. We have unlikely here, so that probably is your 25%. And then we have it's impossible, it's not going to happen. So if you, for example, if you have a 6-sided dice, and what's the probability of rolling an 8? It's not going to happen because there is no 8 on there, so that would be an impossible event. So here in example 1, we're going to apply this here, and they got some examples. Tell whether each event is impossible, unlikely, as likely as not, likely, or certain. Then tell whether the probability is 0, close to 0, a half, close to 1, or 1. So in the first example, it says you roll a 6-sided number cube and the number is 1 or greater. Well, if you're going to get 1 or greater, that is certainly going to happen. The probability is 1. You roll 2 number cubes and the sum of the number is 3. This event is unlikely to happen. Its probability is close to 0. So if you take your example, you got 2 cubes, okay, and the sum, so that means you have to add those together. So you have the probability of a 1 and a 2. You have a probability of a 2 plus a 1, and that's it. Out of all the opportunities of being able to roll this, only these 2 here have a chance of getting the number 3. So it's unlikely that that's going to happen, okay? So it's definitely going to be down in this area somewhere here, okay? Now, we didn't talk about how many events could occur, but we did talk about these 2. We didn't talk about the total amount. And then C goes on and does a similar thing, but you have to look. The next thing we have to look at is what we call our sample space, and it's a set of all possible outcomes for an event. It can be small or it can be very large. Okay, we got some examples here. And then I said before, we need to pay attention on how you write the probability of an event, and it's this P and then whatever the event is, okay? So the number of times that the event occurs over the total number of times that it's likely possible to occur, okay? So if we look at number 2 here as an example, so if we look at example number 2, what is the probability of rolling an even number on a standard number cube? We have 2, 4, and 6 are even numbers, and there's a total of 6. It's going to be 1, 2, 3, 3 over 6, and if we reduce that, it's going to equal 1/2. So the probability of rolling an even number is 1/2. So looking at an example of your turn here, picking a purple marble from a jar with 10 green and 10 purple, okay, what's the probability of that? Well, we have 10 purple, and then we have total of 20. So the probability of picking a purple one is 10 out of 20. If we reduce that, of course, that's 1 out of 2. So that would be your answer for there. The next thing we have to look at is what we call the complement. The complement of an event is a set of all outcomes in the sample space that are not included in the event. So what we've been looking at is this piece, okay? Now we're going to look at, that was the probability of an event. Now we're going to look at the probability of a complement. So the sum of the probabilities of an event and its complement equals 1. Okay, so we're still talking about our whole numbers there. So like this event right here, that was 1/2. So that was 1/2. Basically, 1/2 plus what equals 1. Well, the complement then would be 1/2 also. Or you can take the 1 minus the probability of an event, and that will equal the probability of the complement. And I'm just going to... Here, there are 2 red jacks in a standard deck of 52 cards. What is the probability of not getting a red jack if you select one card at random? So here's the probability of the event. That would be the 2 red jacks. So that's there. Okay, notice they write probability of the red jacks. And then the complement, you just take the opposite of that. So the probability of not a red jack. Okay, so all they do is they take this and they put not in front, okay? And then that's going to have to equal 1. Well, there are 2 red jacks out of a deck of 52 cards. So 2 out of 52 plus the probability of not getting a red jack. We know that there's a total of 52 cards that have to be in here. So what we're going to do then is we're going to take 52 minus 2, and that's going to equal 50. So the probability of not getting a red jack is 50 over 52, and then all they did here was simplify it. So the probability you will not draw a red jack is 25 out of 26 that you will not select a red jack. So here on number 7, a jar contains 8 marbles marked with the numbers 1 through 8. You pick a marble at random. What's the probability of not picking the marble marked with the number 5? So the probability of picking the number 5 is 1 out of 8, okay? And we know something has to equal, then there's 8 marbles out of 8 total. So the probability of not picking the marble marked with the number 5 then is going to be 7 out of 8. So this is the complement here, and that would be your answer. What's the probability of not picking the marble marked with the number 5? Because the one with the number 5 is this one. So we have some more problems down here to use in the guided practice, and then here's some more guided practice. So if you have any questions, let me know and I'll help you out.